Rates of change and slopes are the next thing we're going to talk about. By definition, the rate of change is a ratio, or ratios we know are also fractions, that describes how much one quantity changes with respect to a change in the other quantity. So rates of change is basically expressed as, in terms of graphs and such, change in y over the change in x, and change means difference, so the difference in y's over the difference in x's. And then if we're talking about 2 points, let's say x1, y1, and x2, y2, then it's the difference in y's, so y1 minus y2 over x1 minus x2. So we're going to find the rates of change for women from 2000 to 225 and 225 to 2050. So I look at my chart, and here's 2000 to 225. Oops. And we're going to find the rate of change. So we have to take the y minus the y and the x minus the x. So I'm going to make points out of these. So in 2000, looking at my women, which are the squares on top, that's this graph here, we have at 2000, 80, and then at 2025 we have 84. So if I find the rate of change there, I take the difference in the y's, put that over the difference in the x's, I get -4 over -25, which is 4/25. And that's the rate of change. And if I go from 2025 to 2050, again, I want to list my points. So at 2025, I have 84, and at 2050, I have 87. And then I take my difference in y's, so it's 84 minus 87 over 2025 minus 2050. We get -3 over -25, which is 3/25. And there's my rate of change there. We notice the two aren't the same. So there is more change here than there is here, because it's one more in the numerator. So we know that a rate of change is constant for a function when the rate of change is the same between any two pairs of points on the graph. And we know also the rate of change is constant for all linear functions. So here we have a set of points, some x and y in two cases, and we're going to see if these are the points of a linear function by checking their slopes. So I'm going to check between these two sets of points, these two sets of points, these two sets of points, and these two sets of points for each function. So let's do the first set. We have 7 minus 2 over -1 minus -2, which ends up being 5 over 1. Second set of points is going to be 12 minus 7 over 0 minus -1, which is, once again, 5 over 1. So far, so good. Let's check the third set. 17 minus 12 over 1 minus 0, which is, again, 5 over 1. So far, so good. And 22 minus 17 over 2 minus 1, again, is equal to 5. Therefore, because these are the same, this is a linear function. Now let's check the other. We'll take a look at this pair, and we have 3 minus 1 over 4 minus 0. which equals 2 over 4 or a half. Check the next set. I have 6 minus 3 over 8 minus 4, which gets me 3/4. Notice these two are not equal, therefore automatically I can say this is not linear. So the rate of change, as we've stated before, is the change in y over the change in x, difference in y's over the difference in x's. And the rate of change is also equal to something we call the slope. And another word for the slope is the rise over the run. The variable m is used to notate slope, and it's the same as the difference in the y's over the difference in the x's. So you'll see in this picture here, slope of a line from one point to another point is how much you rise over how much you run. You can also go this way as well. Rise is the up and down. The run is the across. So if I want to find the slope of this line, I usually take and do my up and down first and my left and right second, and you can start from either point. I'll show you how to do that. Start from this point here, and to get down to this point, I go down, and then I go over. Count how much you go each way. 1, 2, 3, 4 down, and I go 1, 2 over. So if I go the rise over the run, since I went down, that's a negative, and over in a positive direction gives me a slope, or an m value of -2. Now, I can choose to go from another point. That's not a problem. If I go this way, I go up, and then I go over. So my rise in this case is a +4, but since I'm going 2 in the negative direction, my run is a -2. So in this case, I'd have 4 over -2, which is still a slope of -2. It doesn't make any difference which way you go as long as you're conscious of what direction you're moving in. So if I want to find the slope of this, once again, I go my rise over my run, go up and over. Just do the simple counting, 1, 2, 3, 4, up. And then I count over a total of 3, and that's my slope. So now we're not going to have a line to count up and over, but we know that this is just the difference in y's over the difference in x's. So if I take and subtract my y's, I have 4 minus 1, and then I have 3 minus -5. 4 minus 1 is going to equal 3. 3 minus -5 is equal to 8. So this is my rise over my run, or my slope, m. We're going to practice another one. Got to make sure if we're subtracting, we always take the front minus the back each time. So I have 10 minus -8 over -9 minus -7, which gets me 18 over -2 or -9. And if you look at that graph, -9, 10 is somewhere up here, -7, -8 is somewhere here. It looks like when we rise and run, we're going down and over, so that makes sense to have a negative there. Take a look at this slope. Take 10 minus -8 and 3 minus 3. Now you'll notice in this case I get 18 over 0. This over 0 is a problem. You can never divide by 0. This is undefined. So what does an undefined slope look like? Well, let's take a peek at the graph. If I have 3, 10 and I graph that somewhere around here, and here's 3, negative 8. Notice this is a vertical line. This has an undefined slope. So we've seen a few different types of slopes. We can have a positive slope, and a positive slope is just a slope that rises as you move from left to right. So this is a positive type thing here. We can have a negative slope, and a slope that's negative is going to go down as you move from left to right. You didn't really calculate a zero slope, but a zero slope is a horizontal line, and an undefined slope, like we just found out, is a vertical line. And the way I like talking about these two is actually zero slope. If I draw the word zero under the line, you notice the top of the Z looks like a horizontal line. And another word for an undefined slope is no slope. It's different than zero. And if I use the N for no, that no, N has a vertical line associated with the vertical line there. So it tends to work out nice. If a line has a slope of 3/5 and passes through these 2 points, what's going to be the value of W? So we know that slope M is equal to y1 minus y2 or x1 minus x2. And I have my x and y points, and I have a slope. So what I'm going to do is write out this equation. 3/5 for my slope is equal to the difference of the y's, so that's 3 minus w over negative 1 minus 8. I can simplify this, and I get 3 minus 5 equals 3 minus w over negative 9. This is a proportion. Do a cross product. Negative 27 equals 5 times 3 minus w. So negative 27 is equal to, distribute, 15 minus 5w. Subtract 15 from both sides. This leaves me with negative 5w is equal to negative 42. So I divide both sides by negative 5. And I get a value of w equaling 42/5.